I'm Cath. I work at AppDynamics, and you're going to hear about what we do in a few minutes. But first, I just want to give you an outline of my talk. So I'm going to build on a lot of things that Brendan talked about. And I have this very ambitious, unreasonably ambitious idea that I want to share with you. So when we were all in school, we learned about algorithmic complexity analysis, big O notation, big omega, whatever, all that stuff. And these are incredibly powerful ideas, right? They're so powerful that we can prove these deep theorems about the nature of computation. They're so powerful that we reach for them every time we design a new algorithm or a new system. And we think they're so important that we ask about them in like every job interview that we give. So obviously these things are really important. But when it comes to debugging performance problems on real systems, we don't really reach for algorithmic complexity analysis most of the time. Most of the time we reach for data, right? We use dtrace or something like that to gather a bunch of data and then hone in on our problem. And once we've honed in on it and said, oh, this little part of the code is the problem, maybe then we use algorithmic complexity analysis. Or more often than not, there's just like some stupid bug that we have to fix. So my very ambitious idea is that maybe someday we can have methodologies for empirical performance analysis that are as concise and simple and powerful as algorithmic complexity analysis is. So over the past few years, I've worked on a few different tools that do performance analysis for very different vertical markets. And my approach to try and make some little baby steps towards this sort of grand theory of performance analysis is to just show you those different tools and how they're similar, how they're different, and just try and understand some of the concepts behind them. And then I'd like to hear your guys' stories about what you use, what works for you in your domain, and maybe together we can figure out something more general. So the first tool that I'm going to show you is called Adobe Scout. Before I came to AppDynamics, I worked at Adobe, and we built this tool for game developers to understand the performance of their games. So I think we have some folks here from Zynga, and I know that actually those guys were using this tool when I was at Adobe. I don't know if they are anymore. But I'm going to show you an example of it. So I'll just pull up an example of a game, and this is a game some of you may be familiar with. If you have opinions about it, I don't care about your opinions. So as the game loads, I just want you to watch the performance of the game and how it looks like it's performing to you. So there's this loading screen. This part's fine. I have no problem with this part. Okay, now you see the world map. Things start to pop into view. Things are kind of animating, but it's kind of jerky. There's jerky animations going on. Okay, and now everything is smoothed out, and I can actually play the game. So that initial period of sort of like, it's kind of there, but it's kind of not quite there yet, as a developer of this game, that's something that I would want to diagnose. So let's pop into Scout and see what that looks like. So this is Scout, and right away when you open it, you see there's some kind of data flowing in. So most games are built around this concept of frames, right? You do a frame of animation, and then you do some game logic. Then you do another frame of animation. And generally, if the frame rate is nice and consistent and smooth, your game is running well. And if the frame rate drops, the game performs poorly. So what you see here in Scout, each one of these bars represents a frame, a single frame of animation. And the height of the bar represents how long that frame took. And as long as the bars stay under this red line, which represents 30 frames per second, then we know that the game is performing reasonably well. Anytime it spikes over the line, then we kind of know there's a problem. Does everyone understand the basic, what you're looking at here? All right, so I'm going to actually stop this session so that, and I'm actually going to open a preloaded one for the demo, so we can just get our bearings. So looking at the session from the beginning, we can see there was all this spikiness that happened while we were loading the game. And then things kind of smoothed out for a little while, and then there were a couple more weird little spikes, and then after that it was mostly smooth with maybe the odd spike here and there, and then finally like the game is running smoothly. So this is what we want to diagnose. So Scout makes it very apparent where you have a problem, and that's kind of one of the important principles I want to highlight. So right here is a big spike. Let's just pick this one. This frame looks like it took about 5 to 8 times longer than it was budgeted. So I'm going to click on that, And as soon as I click on the frame, we get this drill down of what code was executing in the frame. So let's see if the zoom works. Zoom work? Yeah, awesome. All right, so we can see that the top level event handler that fired at the beginning of this frame was this timer. So this timer fired, that caused us to load a tooltip. So that's actually kind of our first indication that something weird is happening. We have this huge spike because we wanted to show a tooltip. That doesn't seem right. And then it looks like down here, we're processing some XML. And if I zoom out, you can see we actually spent 26% of the time, 65 milliseconds, processing XML. So right away, we've sort of honed in on a problem. That may not be the only problem, but it's definitely a problem. And as the developer of this game, I would sort of go and figure it out. So there's one more thing I want to show you in here. So let's pick one of these other frames. Now, all these green frames here, these guys are not over the red line, but they're pretty close, and there's a lot of them in a row. So I think they're interesting. So let's just pick one of those. Again, we'll look at the code. Now this time, there was this onEnter frame event, and then we tried to render a row, whatever that is, and we got down here to rendering this bitmap, and then it looks like we spent most of the time in rendering a bitmap. So that's sort of helpful, but it's not super helpful because, like, obviously the game's going to be rendering bitmaps, and if you spend time rendering bitmaps, you know, that's kind of expected. So what we need is a different perspective on the data. Luckily, we have that. If I pop open this panel, this shows us an actual graph of the screen that the user is seeing, and each one of these represents a display object, or a visual item in the display tree that was re-rendered in this frame. So if we jump back to the game, you can actually see that the game kind of consists of a central world map and then all this chrome stuff around the outside. And in Scout, it looks to me like all the stuff that got re-rendered in this frame was all the chrome stuff. So that's kind of weird because we're 17 seconds into the game. The user hasn't done anything. I didn't click on anything. And we're re-rendering all the chrome on the outside of the app. So that's sort of another way of drilling down and figuring out what the problem is. Now, as a game developer, I would go look at the code and say, well, why am I re-rendering that stuff? So that's actually all I want to show you about Scout. And I just want to point out what I think are some of the core principles here. The first thing is we defined what is sort of the central currency of this analysis tool, which is frames. And we did that because for the types of apps that we're trying to optimize, frame rate is very important. And so frames are kind of the most important thing. And once we define the central currency, you can immediately see where there's problems and where there's are not problems. Second thing is, you guys have probably seen a sampling profiler before, a thing that shows you which functions were called and how much time you spent in them. But my experience is they're usually not that useful because you take a sample of like your entire session of using something, and it says, well, you spent 40% of your time doing rendering. And you're like, okay, well, is that bad? Is that good? I don't know. What we did differently here is first we found a problem, right? We know there's a problem in that frame, and then we drilled into there to try and diagnose the problem. So it's like showing you more data in the context of where you already know there's a problem. And just the third idea is this idea that sometimes you need multiple perspectives. Sometimes you need a different perspective on the same data, or sometimes you need a different data set or kind of overlapping data sets. And then once you get the right perspective, the pattern just jumps out at you. And you don't need to do too much more hard thinking. So there I was working at Adobe, working on Scout, and I heard about AppDynamics. And AppDynamics is, in my mind, like Scout kind of times 100,000 or so. So what we do is also, we make a performance analysis tool, but it's a really different market. We help enterprise web app operators understand the performance of their web apps. So these are guys like Netflix and Williams-Sonoma and Orbitz and StubHub and, you know, big websites that probably a bunch of you guys work for. And they have all this stuff deployed in production, and they want to understand like why it sucks, like Ryan said. So AppDynamics creates this thing that we call an agent that you stick inside your app code, and you deploy that to production with the rest of your production code. It gathers up a bunch of metrics, and then it sends it back to the AppDynamics UI. So when I heard about that, I sort of jumped at the opportunity to work on that, because that's like so much more data, such a more complex environment, and I thought that was pretty cool. So let me show you AppDynamics. Don't look. All right, so this is totally different, but it's also performance related. The first thing you see here is this thing we call the Flowmap, and this sort of helps you understand what the topology of your application is. So in this app, it's like some demo, simple e-commerce site. It has a front-end e-commerce tier, which serves the web pages, and there's 2 servers in that tier. And then the e-commerce tier, in order to do its job, calls out to this MySQL database, but it also calls out to this inventory system over REST API or something like that, which in turn calls to its own databases, and the e-commerce guy also has to talk to this order processing thing through this message queue. So AppDynamics actually automatically figures this out for you. And oftentimes people will realize they'll get interesting insights just from that alone. They install the agent, they get this thing up and running, and all of a sudden they see their app laid bare in front of them, and they're like, oh my god, I had no idea that that thing talked to that thing. So that's pretty cool. So over in the corner here, we can see the amount of load the site is getting. So it looks like we're getting 68,000 requests per minute. You can see the average response time. We could see any errors if they were happening. Amazingly, there's no errors right now. And on the right, this is the part that's actually really interesting. I would argue this part should be in the middle, but it's on the right. There's all this stuff about business transactions and whether they're healthy or not. So AppDynamics chose the central currency of the system to be this thing called a business transaction. And that's basically like, imagine you're on an e-commerce site, searching for something, viewing an item's details, adding it to your cart, checking out, logging in, logging out. They're sort of user operations. And the idea is that, well, if we can track those user operations as they flow through this distributed system, we can tell you, how many of them went well and how many of them went poorly. And that gives you a metric that directly correlates to your user's experience, right? If people had a slow time checking out, then there's a real problem. As opposed to looking at some sort of system metrics like, CPU usage or memory usage. Those may have nothing to do with what your actual users are experiencing on your site. So this is kind of interesting right now. 1 million requests came in, and they're all perfectly normal. It's so many that it averages up to, it rounds up to 100%. But there's still 339 people having a bad time on my website. And those might be people who are going to buy stuff. So I kind of want to actually help them solve their problems. This kind of goes to what Brendan was talking about. You can't just look at averages. You can't just look at, well, what's the average user's experience? Because here you may have just lost 339 sales because these people had a very slow experience on your site. All right, so once we've identified that, we can drill in. And now what we get is a list of actual individual transactions that a specific real person did while they were at your site. So some guy was on the send items page while he was on the view cart page, and he tried to do the send items action, and it took 10 seconds. So that's bad. So if we double click on that, we can drill in. Again, you see the flow map, but this time it's the flow map just for this one request. So this shows you the exact path that this request took through this distributed system. And you can see it took 8 milliseconds on the e-commerce tier, it took 7 milliseconds on this tier, and then whoa, it looks like it took 10 seconds talking to this database. So we've sort of immediately narrowed down where in this whole system the problem is. We drill down and we can actually see the exact line of code that's causing the problem. But again, we kind of have the same problem like we did in Scout. It says it's executing a query. Okay, fine, like my app is always going to be executing queries. We want to know what query it was. So we can jump over to a different view and actually see the query that ran. In this case, it was inserting something into the order request table. So now I can go to my DBA or whatever, or my developer, and I can say, dude, sometimes when I insert stuff into this table, it takes 10 seconds. So, like, go fix it, right? And then he can use all types of other stuff, dtrace and whatever else, to figure out exactly what the problem is. So that's a really, really brief overview of what AppDynamics does. And I just think there's some interesting similarities here. So the first thing is this idea of defining your core currency, something that correlates with what your users are actually experiencing, as opposed to some kind of arbitrary system metric. Then there's this idea of drilling down, getting more data where you know there's an actual problem, as opposed to just more data. And then this idea of getting multiple perspectives on the data. One thing that's a little different here is that we're aggregating over all these different users. And it actually becomes harder to define what a good experience is versus what a bad experience is. In Scout, we just said if it ever goes above the red line, then there's a problem and you have to investigate it. Here it's a little more subtle, because if you're on an e-commerce site, it's okay if checking out takes a few seconds. But when you're searching for something, that should be instantaneous. So there's kind of different thresholds and different user expectations around these different things. And that's a new problem that we have to deal with. In AppDynamics, we deal with that by having these sort of moving averages, and then we say that if a given request was too many standard deviations outside the moving average, then it was a slow request, and so on. That's just one way of solving the problem, but I think it's an interesting problem that we have to deal with. All right, so that's app number 2, some similarities, some differences. The third one I want to show you is another AppDynamics product. It's actually what I work on at AppDynamics. So our traditional product that I've been showing you is great, and it's deployed on all these hundreds of customers, and they get all types of value out of it. But it has one kind of major shortcoming, which is it only measures what happens on your servers, right? It's only measuring what's going on inside your data center. But your customers aren't sitting inside your data center. They're sitting on their laptop, like hopefully on the beach or whatever, and on their BlackBerry, like in a subway that's going through a tunnel. And so the experience that they have in their actual web browser might be really different than what happens on your server. In other words, your servers can all be working perfectly fine, but people are still having a crappy experience on your site. So if you really want to know what people are experiencing, you have to take it further, and you have to measure what happens in the web browser. And that's what we did with EUM. So we built this thing called a JavaScript agent, kind of like these server agents. It's a little JavaScript module that you put in your page, and then it tracks, the performance of your user's experience on your site. And it computes a bunch of metrics about how long it takes to go between pages, and when the site sends XML HTTP requests, how long do those take to come back, and stuff like that. So looks like I'm going to have to log in again. Don't look. So this may or may not be actual data from our actual corporate website. But I'm gonna leave that open to interpretation. So this is the main view you see when you come to look at EUM data. The first thing you see here is this geodash. Each one of these dots represents a region of the world. The size of the dot represents how much traffic is coming from there, and the color represents whether it's good or bad on average. So you can kind of quickly try and look for problem areas. Down here again, we have this notion of how many requests are coming in every minute, and we have the average response time and whether there's any errors. This time they're not errors on your server, they're errors in JavaScript. And that's sort of the first thing you see. So it looks to me like right now there's a problem in Uruguay. So I'm going to right click on that and say, show me snapshots from here. Now this is just like when I drilled in on the server side. It's going to show me some actual requests from some actual users and what happened actually in their browser.
Can you tell me if they're going through a tunnel?
They're going through a tunnel?
Yeah.
No. So this is actually, I'm going to get there. Hold your question. That's a great question. Okay, I didn't like those. I'm going to look at a different one. Trust me, it'll be worth it.
Does this screen tell you that it always sucks in Uruguay? Or is this, does it highlight that it's different now?
That it got worse now as opposed to before? What?
To provide this site.
Oh, this site itself? This site is like our crappy little dev cloud, and it doesn't have enough power to deal with all this. So yes, we need to eat our own dog food. I'm going to try and just refresh this. This is actually beautifully demonstrating a point that I'm about to make. Okay, it looks like I'm host. We'll have to do this verbally, all right? So, imagine, if you will, a map of the world. I find a problem area. I drill in on it. I see a list of specific users who are having specific requests, specific problems with their requests. I double-click on one of those, and I see that this guy who came to my site, it took him 30 seconds to load the page, right? So, once we drill in there, you can see additional data about exactly how it broke down in terms of, the time from when he started navigating to when he got the first bite of the response. And then the time from that until the page was finished loading, a bunch of subcategories below that. And that can sort of help me start to narrow in on the problem. Now, the problem with all this is that this end user data involves a new element, the backend subdata, which is the network. So these people are accessing the site over the internet, which, as we can see, is a flaky thing. And the internet adds a huge amount of just random noise in terms of how long things take. So we actually have done a couple experiments where we sit on our computer hitting F5 on the same website over and over again all day. And we see that when we do that from the same machine, everything's the same, we still get this very wide distribution in how long it takes to hit a page. What that means is if we just look at one guy's request and it's slow, well, maybe there's a problem, or maybe that was just some network hiccup. So what that tells us is we can't really look at one request. We have to take a much more statistical approach, or a more sort of data analysis-y approach to figuring out what the problem is. And I would love to show you some screens that do that, but I can't. So basically what we do is we sort of slice and dice the data in different ways. And we say, here's the distribution, with heat maps or histograms or whatever, here's the distribution of response times over country. Here's the distribution of response times on different pages, and things like that. So again, we have these similar concepts, right? Defining our core currency, which is a request, and if the request is slow, that's bad. We have this idea of finding a specific user and looking at his problem, but we have this huge new element of noise, which sort of screws up everything and makes it very hard to interpret, and so we have to rely a lot more on statistics. And frankly, we haven't gotten it to the point yet where you can just drill in and figure out exactly what the problem with the code is, because there's so much extra noise in the system. So that adds sort of a new dimension for this thing. So those are some of the tools I've worked on, some of the problems I've encountered. I'd love to talk with you guys afterwards about what you've used, what works. Yeah.
Okay, quickly. So this JavaScript agent sounds wonderful.
Mm-hmm.
Does someone people don't have to program to that. That's just transparent.
Yeah,
It just
yeah.
happens to capture that. Okay.
So if you wanted to use end user monitoring on your site, you can do one of two things. You can download the JavaScript agent, which is just a JavaScript file, and include that in your page source. And then magically data will start appearing. If you use our server product and you're in certain types of configurations, you can actually turn it on so it will just automatically do that for you, right? Because our server agent is already running on your server, well, we can just intercept the requests that come in and add a little extra JavaScript to it. So it can actually be as easy as checking a checkbox, which is, I think, pretty cool. Any other questions?
Yeah, I have a question.
Yeah.
I'm curious about the cost of all these agents. Like, isn't there like a Heisenberg principle at play here? Like, what sort of cost does the programmer have to incur for using these agents? And is it such that you can just scale your way out of it? Like, is that the way that people think about it, or?
So yeah, managing overhead is really, really important, and that's one of the things that actually differentiates us from some of our competitors. That we basically worried about that from the beginning. So the metric that we shoot for is we never want to have more than 2% overhead on your production site, which means you know, if you could do 100,000 requests per minute, now you can do 99,000. I can't do it in my head. 998,000 now, right? And that's something that we actively measure on a variety of things. So yes, there is overhead. That being said, like, we have all these customers deploying this stuff in production. It's solving them tons of problems. And a lot of times it saves them so much money of servers they don't have to buy that they think it's worth it. And it's something that we basically really worry about. Same thing with JavaScript. We measure that and we make sure the overhead isn't too much there.
Any of the stuff open source? Sorry.
What's that?
Any of the stuff open source? The
No, nothing's open source. We gotta get paid. Yeah.
What's your billing model?
For which?
So like, there's another company that I've used that makes similar products.
You can say what it is.
New Relic.
Yeah.
And they bill us by post, which in the modern world of virtualization seems kind of weird because sometimes I want a lot of little hosts and sometimes I want a few big ones.
Yeah.
I would much rather pay per, basically like per 10,000 metrics sent to you.
Right.
Than,
so
if that makes sense.
So we should talk after because
Okay.
I'm not a sales guy and I honestly don't know the details.
Sure.
I think we generally charge by the JVM or by the, depends what you're using.
Sure.
What's your app built on?
Ruby.
Oh, we don't do Ruby yet, so don't worry yet. So currently we support Java.NET
Problem solved.
and PHP, and we're going to be adding more.
Sounds like a conversation I have with these guys about D-Tricks too.
What? We don't do that yet?
No, there's Ruby doesn't have such great D-Tricks support yet.
Okay.
It's there in 2 now,
better.
but it's been kind of lagging.
I don't know how much time we have for questions.
not too much, but we, whatever people are,
In terms of why can I not find these in a test environment, considering it's a client, than in production? Why do I have to go to production?
But you can absolutely do it in your.
page?
You can definitely do it in a test environment, and
Okay.
plenty of people do that.
Okay, but why would you do it in production then?
You do it in production because a lot of problems happen in production that don't happen in your test
What kind of
environment.
problems would they be? Would they be at the back end then? Because typically what I find is that when the clients have problems in production, it's actually on the back end service rather than actually the client itself.
Are you talking
Because all
about?
the other problems can be found in simple testing, like the one that you showed us on Facebook. I haven't got a Facebook account for
Uh-huh.
that application itself. You probably could have found that in test.
Yeah.
You
Okay.
didn't need
So
a production environment
so Adobe Scout is targeted generally at people who are developing their apps
Okay, so-
because most of these problems do reproduce in tests.
So why do I need end user monitoring continuously on every page for every user around the world every day?
You don't. Problem solved.
I just know, but I just
you
want to
do.
know why
You may
it's
not-
being sold. I'm just curious to what am I finding? Am I trying to find
it's
people who are in
essentially
trouble?
it's really the same answer, right? You may have people accessing with browsers or devices that you were never able to test with. I just read something yesterday that there's now like 11,000 Android devices
Okay.
in the wild, right? You're never going to test on all those devices.
Because the world's most interesting man needs that, because he only tests his codes in production.
Exactly.
No, but what I'm saying is that production, the system is something different. It's not typically a backend. It's
Well,
more resource
maybe
sharing.
it is, or maybe you've never found it before because you've never done monitoring on the front end.
It's the access pattern. You can never reproduce the access pattern of a whole world coming to you with millions of devices.
Okay, yeah, but they're not all sharing resources until they hit the backend, and that's the part I can
But
monitor.
even the back
So
end,
I'm curious
not
about
at
this
the
client.
same
I don't believe in this. It's a bit of a-
What, for EUM?
everything profile.
No, so again, we have to distinguish between the server product and the client product. Actually, in both cases, we narrow down the amount of data that we collect enormously. So we could collect a huge amount of data, and we have a lot of fairly smart heuristics to try and figure out just the little parts we need. And of course, sometimes we miss stuff, but that means we can actually deploy the stuff in production and not have to pay, us $1 million a year for storing all this data. Thanks, guys.
Thank you.